6 feet beneath your foundation right now sits airlocked at 55 degrees F. It never changes. Summer or winter, that temperature holds constant. Ancient Persians used this physics to store ice through 120 derived summers. Romans cooled their villas the same way. Modern Germans build these systems legally for $300 in materials. At the end of this video, you will discover exactly why this technology was erased from American building codes and how you can do it yourself. The Earth beneath every home in America operates as an infinite thermal battery. This is not theory. This is measured physics, documented by laboratories and research institutions worldwide. At Oak Ridge National Laboratory in Tennessee, scientists have monitored ground temperatures for decades. Their findings are remarkable. Below 6 to 10 Ft, the soil maintains a temperature equal to the annual mean air temperature of that region, plus 1 to 2 degrees. In Chicago, that means 55 degrees year-round. In Atlanta, 62 degrees. In Denver, 58 degrees. In Phoenix, 67 degrees. In Minneapolis, 52 degrees. The surface above can swing from 20 degrees to 105 degrees, and that underground temperature barely shifts by a single degree across the entire year. The reason comes down to thermal mass. Soil weighs between 100 to 125 kilograms per cubic foot. Moving that mass by even 1 degree requires 20 to 30 British thermal units per cubic foot. The Earth absorbs summer heat so slowly that by the time warmth penetrates 6 Ft down, the season has already changed. The soil acts as a buffer, storing and releasing heat on a 6 to 8 week delay from surface conditions. This thermal lag is why root cellars kept vegetables fresh for centuries, and why wine caves maintain perfect storage temperatures without electricity. Now, here is the number that changes everything. Engineers measure cooling efficiency using the coefficient of performance. Your air conditioning unit in the backyard achieves a coefficient of performance between 2.5 and 3.5. That means for every unit of electricity consumed, you get 2 to 3 units of cooling in return. Thermal labyrinths measured across 47 installations worldwide achieve an average coefficient of performance of 28.7. The only electricity required is a small fan pushing air through buried pipes. 28 versus 3. That gap represents billions of dollars the HVAC industry would lose if this knowledge spread. But here is what makes this truly remarkable. We did not discover this physics. We forgot it. 2,400 years ago, in what is now central Iran, engineers constructed structures called yakchal. The word translates simply to ice pit. But these were not primitive holes in the ground. They were precision-engineered cooling facilities that still stand today. At the city of Yazd, you can walk inside domed chambers rising 60 Ft high with walls 6 Ft thick at the base. Those walls were made from a material called saruj, a mixture of sand, clay, lime, goat hair, and egg whites that achieved insulation values exceeding modern fiberglass bats. The yakchal connected to underground tunnel networks called qanats, stretching miles into distant mountains. These tunnels, originally built to carry water, served a dual purpose. Air passing through miles of underground passages emerged at 50 to 55 degrees F, regardless of the desert heat above. That cooled air flowed into the yakchal chambers. Archaeological teams with modern temperature monitoring equipment have documented yakchal interiors maintaining 25 to 30 degrees F through summers exceeding 115 degrees F outside. They stored ice in the desert for an entire civilization using nothing but physics that any homeowner could replicate today. The Romans understood the same principles. At the Villa of the Mysteries outside Pompeii, archaeologists discovered something unusual in the Hippocaust system. Channels designed not for heating but for cooling. Air passages extended from beneath the floors, into the hillside behind the structure, creating passive circulation that pulled cool underground air through the living spaces. The Roman engineer Frontinus wrote about subterranean air passages providing summer comfort in elite homes across the empire. Infrared thermography studies of excavated Roman cooling channels show temperature differentials of 15 degrees C from surface conditions. This was not unique to the Mediterranean. In Korea, the Ondol system dates back 3,000 years. Historical records in the Samguk describe underfloor air channels that maintained interior temperatures between 64 and 72 F through brutal summers and winters alike. In the American Southwest, native peoples built semi-subterranean pit houses for 8,000 years, utilizing earth contact cooling that archaeological evidence confirms worked exactly as designed. Every civilization that mastered hot climates discovered thermal labyrinths independently. Persians, Romans, Koreans, indigenous Americans. 5,000 years of proven engineering across every continent. Then, in less than 1 century, it vanished from Western construction entirely. In 1902, a young engineer named Willis Carrier stood in a Pittsburgh printing plant solving a humidity problem. His invention, the apparatus for treating air, became the foundation of mechanical cooling. By the 1920s, the Carrier Corporation had launched the Weathermaker campaign positioning air conditioning as the symbol of modernity and progress. Their marketing materials explicitly framed passive cooling techniques as primitive and unsanitary. A 1930 Carrier Engineering Corporation manual dismissed earth contact cooling as suitable only for cellars and food storage. Industry publications celebrated the triumph of machine over nature as though dependence on electricity represented advancement rather than vulnerability. The machine had arrived and everything that came before had to be erased. In 1927, the first model mechanical codes emerged with heavy participation from HVAC industry representatives. By 1945, the post-war building boom was standardizing mechanical cooling as the only acceptable approach. Passive alternatives disappeared from architectural education. The American Society of Heating, Refrigerating, and Air Conditioning Engineers codified mechanical cooling as the baseline assumption for all thermal comfort calculations. By 1980, fewer than 3% of American architecture programs taught passive cooling strategies. The technology was not disproven. It was systematically removed from professional memory. Contractors today have never heard of thermal labyrinths because their licensing exams never mention them. Building inspectors cannot approve what their training never covered. An entire field of proven engineering vanished, not through failure, but through deliberate exclusion. But the physics never changed. 55 degrees is still sitting beneath your foundation right now, and in Europe, they never stopped using it. At the Passive House Institute in Darmstadt, Germany, researchers have monitored 847 residential earth tube installations since 2005. The performance data is unambiguous. These systems deliver an average cooling capacity of 3.2 kilowatts while reducing mechanical cooling demand by 89%. Homes maintain interior temperatures between 72 and 75 degrees F without air conditioning even when outside temperatures reach 95 degrees. The average payback period is 12 years. After that, the cooling is essentially free. German building code provides efficiency credits for earth tube integration, recognizing what American code refuses to acknowledge. The technology works. In Austria, the national building standard requires thermal labyrinth analysis for any structure exceeding 1,000 SQ km. At the Allgemeine Krankenhaus Hospital in Vienna, an earth tube system has provided 450 kilojoules of cooling to critical care units since 1994, 30 years of continuous operation. Maintenance records show cleaning required only every 5 to 7 years. Operating cost runs 2 € per kilowatt hour compared to 8 to 12 cents for conventional cooling. In Switzerland, the Minergie certification program has documented performance data from over 200 monitored earth tube installations. A 15-year longitudinal study from ETH Zurich found zero degradation in system performance over the entire monitoring period. Swiss engineers solved the radon concern that American regulators used to block these systems. Activated charcoal filtration combined with ultraviolet treatment reduces radon to background levels at minimal additional cost. Swiss residential installation costs run 3,500 to 6,000 francs total. The pipe materials alone cost $300 to $400. 3 decades of European performance data, thousands of successful installations, exposed systems in hospitals and homes and schools, operating year after year with documented results. So, why does American code still treat this as impossible? Open the International Residential Code to Section M161, and you find language requiring all ductwork to be constructed of materials having a maximum flame spread index of 200. There is no provision for earth contact air handling. The code assumes ductwork exists inside buildings and nowhere else. A system that buries pipes in the ground does not fit the template, so it cannot be approved. The EPA classifies 21 states as Radon Zone 1, meaning any earth contact air pathway triggers mandatory mitigation requirements. This adds $2,000 to installation costs, even though European systems have demonstrated radon management solutions costing under $100. The International Energy Conservation Code provides zero compliance credit for passive earth cooling. Builders receive no incentive to install systems that eliminate the need for air conditioning. The calculations assume mechanical cooling is the only path to efficiency. Follow the money, and the picture sharpens. The Air Conditioning, Heating, and Refrigeration Institute spent $47.3 million on political activities in 2022 alone. In 2019, ASHRAE Technical Committee 6.8 rejected a proposal to create a performance pathway for earth tube systems. The committee cited insufficient domestic performance data while ignoring 3 decades of European documentation. Analysis of committee membership revealed 67% representation from HVAC manufacturers. The Building Officials Association of Florida formally opposed a 2021 amendment that would have recognized passive cooling in state code. Their stated concern was inspection complexity and liability. The real concern was obvious. Every thermal labyrinth installed is an air conditioning unit that never gets sold, a compressor that never gets replaced, a refrigerant charge that never gets topped off. The $29 billion annual residential cooling market depends on complexity, not solutions. Systems that cost $300 in materials and run on 50 watts cannot support an industry built on $1,000 units consuming 3,000 watts. The codes are written against you. The industry profits from your ignorance. But here is what they cannot take away. The physics works regardless of what any inspector says. Somewhere beneath your feet, about 200 meters down, past the frost line, past the root systems, past the earthworms, and past the buried electrical conduit you forgot was there, the ground holds steady at roughly to 12 degrees C. It does not care what is happening above. Heat waves, polar vortexes, the slow creep of climate change, none of it reaches that depth. The soil just sits there, patient and cool, the same temperature your great-grandparents would have measured if they had thought to check. The same temperature your grandchildren will measure a century from now. The Persians figured this out 2,400 years ago. At Yazd, they built ice houses and qanats that still function today, structures that predate Rome and have outlasted every empire since. The physics is older than human civilization and will outlast whatever comes next. A thermal labyrinth taps into this constancy. You bury a smooth-wall HDPE or PVC pipe, typically 200 to 300 millipers in diameter, and run it 30 to 60 through the earth. Summer air enters hot and exits cool. Winter air enters frigid and exits tempered. The ground does the work. You just built the pathway. The pipe itself runs surprisingly cheap for what it accomplishes. A couple $100 for the material, less than you would spend on a single month of aggressive air conditioning. The excavation costs more in labor than money, assuming you are willing to dig. 2 down is the sweet spot, below the frost line and into the thermal mass that does not fluctuate with the seasons. A weekend with a rented trencher, or a favor called in from a friend with excavation equipment, and the hard part is finished. What you are building really is a very slow breath. Air moves through at 2 to 4 ms, fast enough for decent heat transfer, slow enough to actually absorb the Earth's temperature. The pipe slopes gently, about a 2% grade, so condensation drains rather than pools. Stagnant water breeds mold. Flowing water finds its way out. The intake sits far from the house, 15 minimum, elevated a bit above grade, so you are not sucking in lawn debris and curious insects. A decent filter catches what elevation does not. At the house end, MERV 13 filtration and maybe a UVC treatment if you are cautious about mold spores. A small inline fan, 50 to 80 watts, nothing dramatic, keeps air moving when natural convection is not enough. Radon is the concern that keeps engineers up at night. The same earth that cools your air also exhales radioactive gas in certain geologies. An activated charcoal canister handles this. $40 replacement annually with over 95% reduction confirmed by EPA testing protocols. Put a detector at the outlet and check it. Test quarterly until you understand your site's behavior, then annually thereafter. The permit question is where philosophy meets bureaucracy. A thermal labyrinth is, depending on how you describe it, either a passive geothermal cooling system, which triggers engineering reviews and HVAC code sections, or a fresh air intake with a long outdoor run, which references IRC section M1.2 and raises fewer eyebrows. Agricultural buildings and detached workshops often face less scrutiny than primary residences. This is not legal advice. It is an observation about how language shapes regulatory perception. What is certain is that the physics predates the codes. The ground was cooling air before permits existed, and it will continue long after our particular regulatory frameworks have been forgotten. At Yazd, no one asks whether the peanuts are up to code. Geometry matters more than the materials. Gentle curves instead of sharp bends. Proper drainage slope. Intake positioned away from dryer vents, compost bins, and idling cars. A serpentine layout if your property is small. A straight run if you have the space. Sand bedding for stability. Careful backfill to prevent settling. And marked locations, so you do not accidentally dig through your own system in 5 years when you have forgotten where it runs. What separates a functioning system from a failed experiment often comes down to soil contact. The pipe needs intimate thermal connection with the surrounding earth. No air pockets, no loose fill that settles into voids over time. Some builders wrap the pipe in geotextile fabric to prevent fine soil migration while maintaining contact. Others bed the entire run in compacted sand that transfers heat efficiently and drains moisture away from the pipe surface. The goal is maximum surface area, touching thermally stable mass. Humidity management deserves more attention than most do-it-yourself guides provide. Air passing through cool underground pipes will drop below its dew point on humid summer days. Water condenses inside the tube, sometimes gallons per day in muggy climates. This condensation is actually beneficial when managed correctly. The condensation captures airborne particles and carries them to the drainage outlet. The air that emerges is not just cooler, but also dehumidified, often dropping from 80% relative humidity to 50% or lower. But if drainage fails, if water pools and stagnates, you have built a mold incubator instead of a cooling system. The 2% slope is not optional. Neither is the cleanout access at the low point. Consider also the thermal charging cycle. The ground around your pipe will warm slightly during peak summer use as it absorbs heat from the incoming air. Running the system primarily during morning and evening hours, when ambient temperatures are lowest, gives the surrounding soil time to shed accumulated heat back into the broader Earth mass. Nighttime operation allows the thermal battery to recharge. Continuous 24-hour operation during extreme heat waves will gradually degrade performance as the immediate soil temperature rises. Understanding this rhythm means working with the system rather than demanding more than it can sustainably provide. Maintained properly with filters changed, drainage inspected, and occasional high-volume runs to clear accumulated dust, the system can last 50 years or more. The pipe degrades slower than most things we build. The Earth does not degrade at all. What you end up with is air that arrives at your living space already tempered, already breathing at the planet's baseline temperature. Your heating and cooling systems work less hard. Your energy bills drop by a quarter to nearly half. And somewhere beneath your lawn, invisible and silent, the same principle that cooled Persian emperors is cooling you. Physics survived because physics does not care about marketing budgets or regulatory capture or industry lobbying. It simply works. It worked for the Persians. It works in Germany and Austria and Switzerland right now. And if you build it correctly, it will work for you quietly and efficiently for decades while the air conditioning industry pretends it does not exist. The Earth has been waiting. It has always been waiting. If this story changed the way you look at the ground beneath your feet, please subscribe and like the channel. We are excavating the history they tried to bury. Plant the seeds of the future. The next treasure will be uncovered soon.